This is 5.2, the sum and difference formulas, and this is video part 1. Now, you'll notice that right off the bat we have 3 formulas for sine, cosine, and tangent of a sum and a difference. These formulas are actually 6 formulas. You'll notice that they're both 2 in 1. Now the top one says sine of u plus v. So notice the plus is on the top. So if you're going to be doing the sine of u plus v, you're going to go ahead and use the top sign in the formula, which is also the plus. If you were going to do sine of u minus v, you're going to use the same formula, only with a minus sign. Now you'll notice in the cosine formula that the plus switches to a minus, and the minus switches to a plus. So then the same happens with the tangent. So these are actually 2 different formulas just written in one. Now, we're going to use these formulas to find the exact values of some trig functions. So let's go ahead and just look at this first example, the cosine of 75 degrees, and we're supposed to find the exact value. That should be a hint right away that I'm going to go to my unit circle, and I have to use my unit circle to help find these values. Remember, exact value, we're going to use our unit circle. The issue I hope you're noticing is that 75 degrees is not on our unit circle. So I want to take 75 degrees and try to break it up into a sum or a difference. Now, some options could be 60 plus 15. That equals 75 degrees. The problem is that 15 degrees isn't on our unit circle, so that's not going to work. Are there any values on our unit circle that either add or subtract to make 75 degrees? I hope right now you're thinking 30 plus 45. 30 degrees and 45 degrees make 75 degrees. So let's just go ahead and rewrite this as the cosine of 30 degrees plus 45 degrees. Now, I'm finding the cosine of a sum. So I'm going to go up here to my cosine formula, and I'm going to use the cosine of a sum formula. That means I'm going to use this formula in the middle, and I'm going to use the signs on the top because I'm having a sum. When I plug those in, I get cosine of the first angle, 30 degrees, times cosine of the second angle, 45 degrees, minus sine, now again, sine of the first angle, 30 degrees, times sine of the second angle, 45 degrees. And I can find all those with my unit circle. If I go to cosine, the cosine is the x value at 30 degrees. I get root 3 over 2. Times the cosine of 45 is root 2 over 2. Minus, and I do the same thing with sine, and I'm going to get 1/2 times root 2 over 2 when I use that unit circle. And if I multiply straight across the top and straight across the bottom, I get root 6 over 4 and root 2 over 4. And the nice thing is that I have common denominators, so I can combine that into just one fraction. And that is my exact value of the cosine of 75 degrees. So I was able to find the cosine of 75 degrees using only my unit circle. And to do that, I had to break this up into a sum of 2 different angles. Notice that the cosine of 30 plus 45 does not equal the cosine of 30 plus the cosine of 45. Let's just see what that would be. The cosine of 30 degrees is root 3 over 2. The cosine of 45 degrees is root 2 over 2. And here I would get root 3 over 2 plus root 2 over 2 all over 2. And you'll notice these aren't the same thing. This is not possible. Instead, you have to use that formula. Let's look at another one. Find the exact value. This time we're dealing with radians. So I'm going to look at my radians and I'm going to look for two angles that either add to pi over 12 or subtract pi over 12. First off, my unit circle isn't in 12ths. So let's just take a second on the side here and let's take a couple of these and turn them into 12ths. Pi over 3, that's 4 pi over 12 when I multiply by 4 and 4. 3 pi over 12 here, and 2 pi over 12 there. Now, I want to know, can I take any of these over here and either add or subtract them to make 1 pi over 12? Right off the bat, I see that I could subtract pi over 3 and pi over 4. That would make pi over 12 if I subtract those. I could also subtract pi over 4 and pi over 6. Either one of those would work. Let's go ahead and use pi over 3 minus pi over 4. Now, this time we have cosine difference. So we're going to use the plus in between our two. And let's just rewrite this as the cosine of pi over 3 times the cosine of pi over 4 plus the sine of pi over 3 times the sine of pi over 4. If I go ahead now and find all those, let's go to pi over 3, and the cosine there is 1/2 times the cosine of pi over 4, root 2 over 2, plus the sine of pi over 3, root 3 over 2, times another root 2 over 2. And I get root 2 over 4 plus root 6 over 4. And again, I already have common denominators, so I can combine the tops and leave the bottom the same. Let's look at the next example. The sine of 7 pi over 12. Let's think back for a minute to what we just had on the side here. Pi over 3 was 4 pi over 12. Pi over 4 was 3 pi over 12. And over here we had 2 pi over 12. Can you add either of those or subtract to make 7 pi over 12? Go ahead and figure it out and rewrite sine of 7 pi over 12 as a sum. I hope you chose 4 pi over 12 and 3 pi over 12. So pi over 3 and pi over 4. I can rewrite this as sine of pi over 3 plus pi over 4. Go ahead now, pause your video, see if you can pick the right sum or difference formula to use and plug those values in. You should have chosen the top formula, and we're going to use the plus sign in the middle because we're dealing with a sum here. Now notice this one sets up a little differently than the cosine formulas. This time we're going to have sine of pi over 3 times cosine of the other angle, pi over 4, plus, now we need cosine of pi over 3 and sine of pi over 4. Notice I'm just plugging them into the formula above, sine, cosine, cosine, sine. Now we go ahead and use our unit circle and find the exact values. This sine of pi over 3 is root 3 over 2. Cosine of pi over 4, root 2 over 2. Plus cosine of pi over 3, 1/2. Sine of pi over 4, root 2 over 2. When I multiply, I get root 6 over 4 plus root 2 over 4, and those combine to root 6 plus root 2 all over 4. There's my exact values of the sine of 7 pi over 12. Okay, let's move on. We're going to go the other way now. Now notice we haven't looked at the tangent formulas at all yet, but we're going to go the other way. I want the exact value of this thing listed here. Right off the bat, you should be thinking, you know, 80 degrees and 20 degrees are not on my unit circle. But this looks a lot like this sum or difference of signs. Look at it. It looks just like this. I'm sorry, the sum, right? Sine, cosine, cosine, sine, and it's minus. So it looks like the difference of the signs. So I'm going to take these and actually rewrite them as the sine of 80 minus 20. So 80 goes in place of the alpha and 20 in place of the beta. Now if you rework that the other way around, you'll get the thing listed above. So I just rewrote this as sine of 80 minus 20. And the great thing there is 80 minus 20 is 60. And the sine of 60 degrees is root 3 over 2. So this time I went the other way. And I rewrote it smaller instead of longer. I used the formula backwards. All right, this is where we're going to end our video for today, and we will continue tomorrow.